Hi everyone, and welcome to my session here at the Global Azure Bootcamp. It's really great to be here with the Azure community. And today I want to talk a little bit about modern continuous delivery on AKS, on Azure Kubernetes Service. And for this, I will be using open source software, where I'm also an active maintainer. The software is called Keptn, but I will also present a couple of concepts that are generic and not tied to this one specific software. This content will be around, let's say, 30 minutes. Then I will also have a demo. And I'm very happy also to answer questions during this presentation. So please put them in the YouTube chat, or if you're on Discord, also put them in the Discord channel. I try to watch both channels a little bit, especially at the end of this presentation. And then I'm happy also to discuss this. My name is Jürgen. I work at a company called Dynatrace. Maybe you've heard of it. It's also, it has a huge headquarters here in Linz. We are all virtually in Linz right now. Unfortunately, we're not at the office, and I'm not at the office, so you can only see my background here in my home office. At Dynatrace, my role is a technology strategist, and I'm heavily involved in the Keptn project, which is an open source project that has been initiated at Dynatrace around 2 years ago, I think. And in this project is basically the technical implementation of all the concepts that I will be talking about today. If you then think that is something that you want to learn more, I put a couple of links here on this slide. There will also be the links at the very end of the presentation. And I can also share the slide deck on the Discord channel. So if you've already joined, please also make sure to join the specific channel for this presentation, and you will also find the slides there. So let us get started with this topic, modern continuous delivery on Azure Kubernetes Service. And I don't want to start with the solution. I actually want to start with the problem that we want to solve, because you also want to know if the presentation I'm giving today, and if the concepts I'm presenting today, if that will also solve your problem. So let us start with the problem that we see in a lot of large organizations, to be honest. The problem is that with all the delivery deployment pipelines, they become very, very complex. And we got one quote from a Keptn user that is actually saying the automation they have to build around their microservices even becomes more complex than the microservices itself they deploy. This comment and this quote comes from Christian. He's a senior Devops engineer at a company called ERT, and he's based in Germany. And he is maintaining and responsible for a lot of projects and a lot of pipelines. So it's not only one pipeline he has to maintain, but a lot of pipelines. And those pipelines, they become very, very large. So it's not only a couple of lines of code, but it's actually thousands of lines of code. And the problem is that if you ever want to change this, and if something is broken, he has to go through all this pipeline code and fix the error, and not only doing this for one, but probably for all the project spanning of all the different, all the pipeline spanning for all the different projects. The second problem is that you have a lot of problems, probably, and they might be a little bit different in the details, but in general, you always want to deliver software to your end users. And what you do if the pipeline is working, then sometimes you just copy and paste this due to the lack of standards and due to the lack of better automation options. So actually, at Dynatrace, our colleague here, Dieter, he was sharing the story with us that in the beginning, you have maybe one service, one microservice in one pipeline. But as a team, you of course have more than one microservice. You have a project that contains a couple of microservices and a couple of different pipelines. So you end up with more and more pipelines. And the problem is, it's only one team, but then you also have more teams. And if the pipeline is working, then you might end up to just copy and paste whatever is working, and you end up with a lot of code duplication. And if you ever want to change some tooling, if you ever want to fix some issue in the pipeline, if you want to add some new functionality to a pipeline, you duplicated all this code, and you have to basically go through all these pipelines and change and update all these pipelines. So that really becomes a nightmare. And a third problem is that the whole quality enforcement and quality checks in these pipelines is not really automated. It's very hard to automate, and there has been no standard yet. And we got this quote from another Keptn user. Roman, he is the managing director of a company called Triscon. They are based in Vienna. And the main problem is that they spend a lot of time on maintaining things instead of innovating and instead of building new things. They could only onboard a couple of applications, and it was very difficult for them to basically increase the velocity and increase the speed of deployment and delivery because of all this maintaining and maintenance of quality checks. And with, let's say, a standard-based or service-level objective-based analysis and a tool that will do the heavy lifting for them, they can spend now more time in actually innovating. So these are 3 stories and 3 problems, and we have built a platform for data-driven delivery and operations automation based on Kubernetes, like Azure Kubernetes Service. And this project is called Keptn. It's available on GitHub. I will share the link also later on. And what it really does is it provides a couple of different use cases, because we've seen these problems. They are a little bit different from each other, but with one solid automation platform and data-driven delivery platform, we can basically fulfill and solve those problems. So with Keptn, you have different options where you want to start. Some Keptn users, they start with quality gates in their CI/CD pipelines. Some of them, they want to go full in and actually build their progressive delivery pipelines and continuous delivery pipelines with blue-green deployments directly with Keptn. Some of the users, they just want to have Keptn as an orchestrator for auto-remediation. So you can pick your use case, and you will bring your configuration. Instead of writing all the pipeline code, you will bring a configuration, and Keptn then does the heavy lifting for you. And you can also bring your tools. So you can connect it, for example, to Azure Devops. You can connect it to even the Jenkins pipeline if you already have Jenkins in your organization. I just watched a talk here at the Global Azure Bootcamp, and they were talking about Jenkins. They have large Jenkins pipelines, and they might be able to include Keptn quality gates in their Jenkins pipelines. So you pick your use case, you bring your configuration, and then Keptn automates this configuration and provides the self-service for monitoring, continuous delivery, reliability engineering, and automated operations and remediation. And this is done through an event-driven process. So Keptn is sending and receiving events, and there is no tied integration of it. That the tools are not integrated in the pipeline, but the tools are separated from the pipeline, as we are using an event-based mechanism here, which I will show you just in a minute. So with Keptn, we are able to solve these problems that I was mentioning earlier, and I just want to share 3 examples here from users. The first one is from Sumit. He's a principal engineer at Intuit. It's a large company in the US. They are basically what we would call here in Austria, you would need Finanz Online to do your taxes, and Intuit, they are providing tax software for American citizens for them to do their taxes. So they are having a tool stack around Argo CD, load tests with Gatling. They're also having Jenkins pipelines, and they're using for Keptn for quality automation, quality checks to enforce the quality of their microservices, and they are doing quite some automated quality evaluations. At Triscon, I shared the story earlier, and their stack also includes Azure Devops, and they are using Keptn for the performance and resilience test automation. So they could increase the amount of performance tests and also increase the amount of tested applications with Keptn, as a lot of things are now automated. And for Christian, they are using delivery pipelines. They are using Helm for delivery. They are using JMeter for the load tests. And they could scale through this automation and include more services into the pipelines, and also increase the stages they have to go through, like a quality ensuring stage, a pre-production stage, a testing stage, all these stages they are managing with Keptn. So let me show you how it works and how we built it and how we can then basically solve this, the problems that I was also sharing earlier. When we again take a look at the pipeline, at the large pipeline, or maybe it's not even large, maybe it's a standard size pipeline maybe also in your organization, but let's say it has a couple of hundreds or even 1,000 lines of code. The size is one problem, but the other problem is actually that there's a lot of information inside these pipelines. They will tell you about the process, what goes first, what goes last, what goes in between. They also tell you about the platforms where you want to deploy. They have all the information about the environments. Maybe then you have copied code from one environment to the other because you want to run your performance tests in each stage. And they have tight integration with all the tools. If you ever want to send a notification to Microsoft Teams because your deployment failed, then you will have this tool integration sometimes directly included in your pipeline. So there is really no clear separation of the concerns. What is important for the developer, what is important for the DevOps engineer that is probably maintaining also the pipelines, and what is important for site reliability engineers that care about the processes and operations workflow and the quality of the software that is running in production. So it's very difficult to put everything or to separate this as part of the pipeline, because it's already put into the pipeline, and there you cannot really give different ownership on different parts of the pipeline. So that's really a problem in larger pipelines. And it's not only Jenkins pipelines. A lot of tools work in the same way, where you just end up with hundreds of lines of pipeline code. So what we did in the Keptn project is that we removed the hard dependencies and integrations from having all these steps and all these building blocks as separated building blocks. So instead of having in the preparation step or in the deployment step directly making, let's say, calls or API calls to the deployment tool and to the monitoring tool to configure it, or even to the testing tools to prepare it next time for the testing stage. Having this separated, having the who is doing what and the process as two different building blocks, so to say. So we built some eventing mechanism in between so that it can become clear which events do you have to generate. So how can I build a process based on events? Let's say there was one event to start the tests, there's one event to indicate that the tests have finished, but that's not really tied to any step that goes before the tests or after the tests. But we have all the events that can describe the process, and we have all the tools that can consume these events, and of course this goes into the tool definition. So whenever we want to change a tool, if you want to move from Slack to Microsoft Teams, you can just remove the Slack integrations, add the Microsoft Teams integration, and then you will receive all the events in Microsoft Teams. You don't have to change the whole process, because these are not two separate things, and you don't have to change all the pipelines, because the pipeline is basically a process definition that stays the same, but what you will do is to change the tooling definition. And this could be two different ownerships, and it's much easier to change this part that is not tied to the process anymore. So, for example, in taking again this large pipeline, what we can do with this large pipeline is that we can drastically remove the complexity of this pipeline by keeping the same functionality, but also basically distributing the responsibility of the toolings into the tool integrations and keeping the process here defined in what we call a shipyard file. So we drastically reduce the automation code. We keep the tooling specific code close to the tooling. The process specific code we keep now in a dedicated file that in Keptn is called a shipyard definition. But you can think of this is the process and environment definition. We have a clear separation of the process and the tools. We can base everything on Git. All the configuration is stored there. We have version control there. We have dedicated permission control with GitHub, for example. And we can build some concept like SLOs, which we use for quality checks. We can build this all into the tooling and then use only the configuration files in the Git repository to basically control which version of a microservice should go into production and which version is not allowed to go into production. So let's first take a look at the shipyard file, then I will show you how you can describe the quality gate with Keptn, and then we will also see a demo later on. So a very simple shipyard file that I took here is basically here just describing, I have a project, or I just called my project the sock shop, and this one is the process definition and the environment definition for this project. I have, for example, here a dev stage that is basically my first environment, the dev environment, and it has a couple of, in this case, it's just one sequence, and it's a delivery sequence. So what has to be done to deliver a new version of a microservice into this stage? And first there goes a deployment, then a test, an evaluation, and a release. And I could also define this here as different deployment strategies. I do not define the tooling directly in this file, but I have the tooling defined in a new concept or in another concept, which we call the Keptn's uniform. But I just basically sketched it here, how the tooling comes into play, because we can see the Helm service, the package manager for Kubernetes, will be responsible for pick up all the events that will be sent from this task. So what we've seen earlier, the separation of concerns and the separation of the process and the tooling. Basically, what Keptn will ensure is that for each task, there will be an event sent out, and tool integrations can listen for these events. So the Helm integration would listen for the deployment instructions, then Helm will go ahead and do the deployment. Once it's finished, it will return to Keptn. Deployment is now finished. Please move on with the next task. And Helm doesn't really know what is the next task. This will all be orchestrated by Keptn. And Keptn can then trigger the tests. And I just sketched here a couple of different testing tools. We have more than one integration, not only with JMeter, but with Locust, Artillery, Litmus Chaos for chaos tests even. So you can just define here which tests or which test strategy you want to execute. You would not really define the actual test files in here, because you could just reuse this file also for different stages, not only for a dev environment, but for a staging or production environment. And you would define which kind of tests. The actual test, the test instructions, like a JMeter file or a Locust file, you would put into the configuration repository, and Keptn will pick it up from there and will pass it to the tool integration. And you have all these tasks defined, so it's very it's a clear separation between the process and the actual tooling, and everything is done based on cloud events, where Keptn will make sure that for each task an event is sent and the tool integration will pick it up. One important step here is the evaluation. So I mentioned earlier, one basic concept, so to say, of Keptn is SLO-based quality evaluation. So with Keptn, you can make sure that you not push anything into production that should not reach production, because we have a quality gate in between, and you can just call this quality gate by calling the evaluation task. So how does it look like? We are using here a couple of site reliability engineering best practices and principles, and we are making use of two of them. The first one is the service level indicator, and we can think of this as a metric, something like the error rate of login requests. So that would be a metric, that's the indicator. And for the indicator, we can also add objectives for each indicator, something like the error rate of login requests. This is the indicator. It must be less than 2% over a 30-day period, or within the last 10 minutes, or during the test duration. So we can really have an objective, and we can make sure to evaluate upon this objective and then make a decision if the objective was satisfied or not, and then we can decide what should happen, if we want to roll it back, if we want to promote it. And on top of service level objectives, we can build service level agreements. In Keptn, we don't put it into code, but it's more a business agreement between a consumer and a provider based on SLOs. So how did we put in service level indicators and service level objectives? So the indicators, again, here, it's basically a metric. We give it a name and the expression how to retrieve this metric. We have integrations with different tools like Prometheus or Dynatrace, where we can retrieve the data. But we already abstract from the actual data retrieval in the service level objective definition, because here we're only interested on a concrete objective, and we want to evaluate, for example, here, the success percentage of some probes. They are basically checking the availability of the application or the microservice, and we can define the success percentage in a given test period has to be higher than 95% for it to pass, or higher than 90% for it to still get like a warning. It would basically mean half the points in this case. And if neither of those two criteria are met, then it would result in 0 points. And you can just write all your service level objectives here as basically as a list. And Keptn will make sure to evaluate each of them and even generate a total score. So how does it look like? You can use a Keptn quality gate by either calling it by the API or triggering it by the CLI. And then Keptn will reach out to the different data providers that are connected, will fetch all this information, the indicators, and will evaluate all these indicators. It will come up with a score, and then at the end, generate a total score. And based on this total score, you can then decide if you want to move it on to the next stage or roll it back or just keep it in the stage, or you want to send out the Teams notification or whatever. But this part does the heavy lifting for you to reach out to all the different data providers and query the data and then evaluate the data for you. So I want to show you now how this actually works. I have a small demo application set up. And what we want to do is we want to push one new version of a microservice application from dev all the way to production. We have an intermediate stage called staging, where we're doing some performance tests and evaluating how this service is actually behaving. So for this, let me switch to my demo environment here. And I have two projects here in my demo environment. One is called the Sock Shop, the other one is called the Unleash project. But in my case for today, we just care about the Sock Shop. And I have 3 stages: a dev, a staging, and a production environment. And I can already see there are 2 microservices that are already deployed in these stages. I can see the latest quality score. This one here in dev, actually, I do not have any kind of quality gate. I just check if it can be deployed, if the image is available. If everything's fine here, we move into staging. There will be some kind of quality checks. So since this takes a couple of minutes, let me just start this. And I think I have it still here. So what I want to do now is to trigger a delivery sequence with Keptn for my project Sock Shop, for my shopping cart application or microservice, and I use this version of the shopping cart. So let's just go ahead, and yes, it's this Kubernetes cluster. And let's go ahead and trigger a new delivery sequence. So the content of the delivery sequence, this is stored in my Shipyard YAML. And we can take a look here in the Shipyard YAML. It will go through all these different stages. It will start with dev. Here's the delivery sequence, first the deployment, then some tests, some evaluation, and a release if the evaluation basically gives a thumbs up. And then we will move into the staging. We also have a delivery sequence that starts when the delivery in the dev environment is finished. And here we have also some deployment. We have a blue-green deployment strategy. That means Keptn will make sure to have a blue-green deployment orchestrated. We are keeping the old version, putting the new version next to the old version, and then just doing a load balancing between the versions, and depending on which version is good, basically we keep the good version or roll it back to the previous version. So we already see, I think, in the Keptn's bridge here, how the delivery is actually going on. So we can already see there is a delivery started here. The tests have already been finished, and now there is some kind of evaluation. So that we can also see which tool was responsible for doing the delivery or the deployment. It was Helm. It was finished in less than 1 minute. Then there was some tests, actually. The cheerleader tests, we did not add any cheerleader test instructions, so they could also, this tool basically skipped this part and returned immediately that the cheerleader test is finished. And now there is some evaluation going on. It will basically fetch some data from, in this case, from Dynatrace to evaluate if something was going wrong here, if we have maybe some error rates, and if the evaluation is fine, it will be moved to the next stage. So it might take a minute for it to be finished to get all the data, but then we will see that we will move on to the next stage. Since I know it takes a minute or two, we can take a look on the previous successful run that I just did as a preparation for the Global Azure Bootcamp today. So let us take a look at the previous run. And we can see in dev, there was the evaluation, and there was a release. The evaluation, basically, it says here, let us take a look on the evaluation staging, because it's more interesting. We get 100% of the points. And we can see here what has been evaluated, what are my service level objectives in this case. So I have 4 service level objectives. Let me just move this box here so we can see it. And I do care about the throughput, the response time, and the error rate. And for the response time, I care about the 95th percentile and the median here. And my criteria on when it's allowed to move on to the next stage, they are a combination of relative thresholds and absolute thresholds. So in this case, it was good. The response time was around 290 milliseconds, and this is compared to the fixed threshold. This is fine because it has to be faster than 600 milliseconds. But also compared to the previous runs, it did not increase by more than 25%. And that's important because with this, you can, with the combination of both, you can really detect some regression in your performance, for example. So it's not, it's good to start with relative thresholds if you don't know any absolute thresholds yet, because you're not sure what is actually the response time of my microservice or what's actually the memory consumption or CPU saturation of a microservice. Maybe you can start with relative thresholds to define, okay, it has to be within a boundary of 10% plus or minus. So you can make sure each new build is basically behaving as the previous ones. So, and I'm doing this with this criteria here, and we can see everything was fine and it was able to move on to the next stage. We can also see there are always some runs that are failing, and I can take a look at them, and they are failing because they just take too long to respond. The response time is a little bit more than 1 second here. And you can already imagine these are some automated tests I'm doing here. So it's always 3 deployments per day. And there's always one deployment that takes a little bit longer, and I can ensure that my quality gates are actually blocking this deployment from reaching my production stage. So let's take a look back if we can already see our current deployment. Oh, current deployment, if it was fine. Yes, here we go. We can already see staging has been triggered. So now we can see the tests are being executed, JMeter started, and the tests are now being executed. We can also take a look at which tests are executed. I told you earlier, everything is based on Git, and I see all my configuration of this project and also all the microservices in the Git repository. So there was just a recent change in staging. It's actually the change that a new version is now deployed in staging. I can already see it here. So let's take a look in the staging branch. And I can see the two microservices that Keptn is managing. I can see the parts microservice. Let me just move this again. And here I can see the deployment instructions for Helm. I can see the quality gate, and I can also see the JMeter files here. And there I do have one JMeter file, and this is basically my instruction for the load test, and this will be passed to the JMeter integration for it to pick it up. And this load file will be used to generate the load for this service in my staging environment. And here I do have my quality gate. I just showed you the quality gate in the Keptn's bridge, in the UI of Keptn, but we have everything defined here. And we can also see the total score it has to satisfy. So if 90% of all of the objectives are satisfied, it's allowed to move on to the next stage. With 65%, you would get a warning, still allowed to move on to the next stage, but anything less than this would block it in this stage. And with the blue-green deployment, it will even roll it back to the previous version. Okay, we can see tests have already finished, and now again the evaluation is going on. So let's say the opinionated way of doing continuous delivery with Keptn is always start the deployment, trigger the tests, do the evaluation, and then promote based on the outcome of the evaluation or roll it back. So this is basically the opinionated way, and we can also see it here in the Keptn's bridge. So with this, we can always come back to this later, but with this, let me move on here in the slides. Okay, so I've showed you now how to do the continuous delivery with Keptn based on the Shipyard file and based on the service level objectives and your quality gates. So the main part here is that you can drastically reduce the lengthy manual approval process. We saw that the quality gate will do this heavy lifting of fetching all the data and evaluating this based on the SLO specification. You might also have your kind of manual approval process currently in your organizations, but the problem here is that it's very difficult to do this manual approval process, and we also saw this in the example of Roman that I showed in the beginning of the presentation, because actually defining what are the correct metrics I want to evaluate, where is the data coming from, is there any noise in the data? Everything is, if you have to do it manually and maybe based on some spreadsheets, it takes quite a while. So it's really a slow and cumbersome approval process for each deployment. And also, I just watched a session earlier at the Global Azure Bootcamp, and they also said they are doing 1,000 deployments. I think it was per week or per month, I'm not sure, but they're doing 1,000 deployments, and they have to check this. They have to check the quality of each deployment. So if you're doing this manually, it takes too long and you cannot really afford it. So you need this kind of automated quality gate. And this is part of Keptn anyway, but you can also use the quality gate in your, let's say, Jenkins pipeline or Azure Devops pipeline. You can just use the part of the quality gate. So you can use Keptn, for example, to trigger the tests or only to trigger the quality gates. But either way, if you have some tests and you have some time period that you want to evaluate, you're using Keptn to reach out to the data provider. As said, it can be Prometheus, it can be Dynatrace, it can be anything else that is providing you the data for the evaluation. Then come up with the evaluation score, and based on this, you can then move it on to the next environment, give it a thumbs up, or roll it back to the previous version. And since everything here is automated, all the API calls are done by Keptn, you can drastically remove the time of the quality evaluation from maybe half an hour or more to around 1 or 2 minutes, depending on how fast the data is available. Then the comparison on the thresholds is done really, really fast. So since we are on the Global Azure Bootcamp, I also want to share with you some integration in Azure Devops. And this integration was actually not done by the Keptn core team, but it was provided from the Keptn community. Bert van der Heden, he's from Antwerp, I think, from Belgium, and they are using Keptn for the customers. They are doing a lot of consulting in the Azure space, and they built an integration to integrate the Keptn quality gates into Azure Devops. So they are orchestrating or they are initiating and starting their tests and the deployments from Azure Devops, but for the quality evaluation, they are using Keptn. And they've built an integration. It's called the Keptn integration. It's available on the Visual Studio Marketplace. You can find it here. And what it can do, it will basically automate the part to reach out to Keptn, to trigger the Keptn quality gate. Keptn will then reach out to the data providers, query all this data, evaluate it, and will then send back the result. So they have a couple of different tasks in the pipeline that you can use in the Azure DevOps pipeline, and they've already built this integration for you to use. So how does it look like? Basically, you also have the SLO-based quality gates as part of the Git repository. That in this case it lives in their Azure DevOps pipeline, I think, and they have quite some quality criteria that they want to evaluate, quite some service level indicators, and they put some objectives upon these indicators. And then Keptn will do the quality evaluation. So they have all the history of the quality evaluations in the Keptn's bridge. They can take a look at it. Some of those lines, they are grayed out here, and that means they have not put an objective upon this yet. So for example, here they have the throughput. They don't have an objective for the throughput, but still they want to query the data, and they want to have the data, maybe to learn from the data, and to later on then set a threshold and set an objective for this data. But they put quite some different quality criteria and service level objectives into the file, and Keptn will then evaluate each of them. So in this case, we can see the error rate was not that good for the last couple of runs, but in total, the quality evaluation, they are reaching here 75%. So they allow it to move on to the next stage, and this is basically the thumbs up, and the quality evaluation is given by Keptn, and the deployment and the promotion is done in Azure Devops based on their, I think they're also running on their Azure Kubernetes Service. So let's wrap it up really quick, and then maybe we still have some time for questions, I think. So Keptn is automation or an orchestrator for your cloud-native applications for data-driven delivery and the automation of your operations. I've not spent too much time on the latter part for the operations automation. I really wanted to focus on the data-driven delivery part, how you can deliver applications on your Kubernetes clusters with Keptn. Keptn is installed in your Kubernetes clusters, and it will provide all the functionality that I've showed you. It will connect, for example, to Helm, so it can orchestrate Helm to do the deployment. It can orchestrate your performance testing tools or chaos testing tools to evaluate either the performance or the availability or resilience of your applications. It has quality gates baked into the core, so based on the service level objective, you can then decide, or Keptn will give you a score if it should move on to the next stage or not. And you can orchestrate multi-stage delivery with Keptn by just adding all your environments and all your stages into the Shipyard File. So with this, I just want to mention how to get started. We have our website, it's keptn.sh. You will find the documentation. You can download the Keptn CLI from there that you will need for installing Keptn. But you can also go to tutorials.keptn.sh, and it will give you a couple of different tutorials that you can use for a quick start. You can even install it on a small VM, for example, that will then run micro Kubernetes on it, so you don't have to bring your AKS cluster, but you can just use a virtual machine, spin it up, install Keptn in the box on it. We just did recently a webinar on this to explain how this tutorial is working. So you can give it a try. It will bring everything up with a demo application already, everything within like 7 minutes, and then you can experience multi-stage delivery, blue-green deployments, quality gates, everything with Keptn. We do have quite a great community out there. I just put here a couple of quotes, what the community is doing with Keptn, how they are using Keptn, especially here. They are using Keptn quality gates, and it really helped to speed up the delivery by 75%. And the important part here is, I think, in all our cloud-native environments and everything is based on automation, to really drastically reduce the manual work by around 80%. So they are now having some way to automate the evaluation step, and this was the most important part for them. Also here at Gitopia, they are continuously evaluating this. So this is the important part, that you have to continuous evaluation as part of your continuous delivery. This is really one crucial part. You cannot deliver anything to production that is not battle tested before production, and you should really base this on some kind of best practices. And we are using here the SRE best practices in terms of service level indicators and service level objectives. So with this, I'm already at the end of my presentation. I think I took around 40 minutes, including the demo here. I'm very happy to answer also some questions. I'm just taking a look here if any questions are coming in. Let me also take a look here. Probably I closed it. It's still open here. So if there are any questions, I'm happy to answer them. I can just start with one question that we often get, and I've not managed it during the presentation. The question that always comes is, does it only work on Kubernetes? And the answer is no, it also works for your legacy applications. It's just that Keptn itself is running on Kubernetes. We can even take a look again into my demo application here. So let me just remove the background here. That makes this a little bit bigger. And we can just take a look at here. qtl get pods, everything that is running in my Keptn namespace. This is basically my Keptn installation. Here we go. This is my Keptn installation. It's a couple of different microservices that talk to each other. It's the control plane plus the execution plane of Keptn. Like we have here the JMeter service, which is actually doing the execution of the tests. We have Helm here that was responsible for deployment. We have Dynatrace here that was responsible for fetching the data. So we have everything here. And you only need to run this on some kind of a Kubernetes infrastructure. You can use keys here, you can use AKS here, you can use micro Kubernetes, Minikube, whatever you want. If you also have your applications managed on Kubernetes and running on Kubernetes, you can, then Keptn can also orchestrate this. Keptn get namespaces. So we can see I do have 3 different namespaces for my application here: the dev environment, my staging, and production. And this is also managed by Keptn. But if you just want to run the Keptn quality gates, you would run only a fraction of the installation portion here. You would maybe not run the JMeter service directly here on the cluster. Maybe you're just orchestrating the tests somewhere else, or starting the test somewhere else. And then you can just connect it, if you want, into your Azure Devops pipeline. If you have more of the legacy applications, into your Jenkins pipelines, so it does not, your applications do not have to run on AKS, but you can leverage the full power of Keptn if you're running on AKS. Let me just double check if there are any more questions coming in. I don't see them yet. And probably in the Discord, but also no questions yet. So then, if you still have some questions, please, you can always reach out on Twitter. It's Etzlstorfer, that's my Twitter handle. You can also follow us on Keptn project or just visit out on keptn.sh. If you're interested in the source code and you think or you want to give us a star here, we really appreciate that. And we even have a Slack channel if you want to follow us there, and if you want to interact with us, we'll also find all the information on keptn.sh. So with this, thanks a lot for joining the session. Have a great rest of the day here at the Global Azure Bootcamp, and hopefully see you all next time. Thank you.